Hello everyone. I'm your PChem 1 TA, Dimitri, if you guys remember me. I'm currently graduated from Stony Brook now, and I see that you guys are taking PChem 2, which is a hard class for me and some other students back in the day. So I just wanted to make a few videos just explaining like some tips and tricks and also some summaries of lessons to help you guys out. So, well, first I'm going to start off with is teaching you guys this general math that you need to know for PChem 2. And PChem 2 is a quantum mechanics class, which means a lot of math. This class is pretty much like a math class itself, but what you're going to learn with wave functions and operators. And they seem difficult at first when it comes to the math, but once you get the math down, it's pretty much just it's simple from there. So let me just go first with the derivative review. And so as you guys know from Calc 1 or Calc 2, that that the derivatives are just finding the rate of change of a function. So for this as example, this would be f prime of x would be the rate of change of x, of f of x. And if you were to take the derivative at a single point, you'll find a rate of change at that point. So let's say f prime of like an arbitrary point A, this will be equal to the rate of change of the function at point A. Alright, so we know with derivatives, there's also something called the product rule, which I know some of you guys do not like. It's kind of annoying to do, but you're gonna need to know this for if you're gonna do stuff with operators and other stuff. And operators I'm gonna get into much later in other videos. You need to know now, but just to let you guys know. So for a product rule, you have, let's say you have an arbitrary function g of x and f of x. You're trying to find a derivative of them together when they're multiplied to each other. This would equal to g prime of x, f of x, plus g of x, f prime of x. And just remind you guys what the product rule is. And some common derivatives are shown on the next page. You guys, I just took this from online. You can just take them from online to know these, or just take notes from here. Uh, but yeah, just learn. You don't have to know all of these. Like some of the trick ones are not necessary. They're not necessary to learn. But yeah, just uh, just get in the habit of doing derivatives and stuff. You're gonna get practice when you're doing recitation and quiz problems. All right, so let me go on to the next topic, and this partial derivatives. You guys didn't know that. I know you guys did that in PChem 1, so I'm just gonna remind you again what partial derivatives are. And they're basically derivative in terms of other functions. Of a function of two or more variables, while the other variables are left constant. You're not going to really see this in PChem 2 a lot, but it's a good thing to know. I'll just show you guys an example here. Let's say you have a function which has two variables, ax and a and y. So then it'll be f of x plus g of y. This is what the function is. If you were to take the derivative of that, you would treat the function, since this only contains since g of y only contains functions of variables of y, right? This is basically treated as a constant, and the derivative of a constant is 0. So the only thing to be left is f prime of x. And it's the same thing for here. If you take the derivative in terms of y, it will be the same case where you're just going to have g prime of y. I'm just going to show you guys another example. Let's say you have, this time, wait, sorry about that. Now you don't have to do the product rule with these at all because if you take the derivative of this, the function b, then this is treated as a constant, which means it's like saying it's one or something. So like one or two or something like that. So then you'll just have g of y times f prime of x. And it'll be the same thing if I did it the other way. So I'll just do a b for short, and it'll just be f of x g prime of y. All right. Now let me review that. That's basically the gist of it. It's just to remind you guys. I'm gonna also post some videos. I'm also gonna share videos in the description to help you guys practice if you need help with derivatives or anything. So let's go on to the next topic, integration. Now, if you learn conceptually what integration is, then it'll help you learn the topics in quantum mechanics much more easier. So it's like you know from Calc 2 or Calc 1 that it's the opposite of derivatives. And finding the integral just means you're finding the area. It means you're finding the area. Finding area from the curve with specific boundaries. Oh, specific bounds, I mean. So let's show up an example here. So let's say we have an arbitrary function f of x, and then we have, if we were to find the integral of this, we would take the integral to the opposite derivative, and it'll be like f of b. Let's specific 2 points, b and a. What is f of a? And if I want to show this on the graph, what we're really doing when we're taking an integral is just doing this. This is f of b, and then what you're really doing is finding the area, which is equal to this above. So right here. Alright, so let's go on to the next thing. And common integrals are shown here. I don't know why I put it down here, but let's just put it up here. You don't need to know all of these. I believe in PChem 2 you're gonna have simple integrals to do. And if they're difficult, they will give you something to where, oh, this is what the integral is or something like that. Alright, so let's go to the next thing would be u substitution. And for u substitution, I'm just going to show a simple example. And I'm also going to put a video in the description on where to practice this. We're evaluating integrals. So let's show an example. So let's say we have a function x to the third over e to the x to the fourth, and we put it in terms of dx. So we're just going to solve the integral and not do any bounds or anything. So let's say that we're trying to solve this integral, right? We have x to the fourth here. So if we want to solve this using u substitution, we find something that solves the derivative. Like let's say here, when we solve the derivative, we'll have the same power as what's here. So let's try to use x to the fourth, right? If we try to solve this with if we take the derivative of this, we would have 4x to the third dx. And so when we do this, we have to divide by 4, so we can substitute this in. And then you guys look at that, we have x to the third dx. So this is what's right here. And we can replace the u right here. So then doing u substitution, we find that we can solve this by replacing these variables. So we have du over 4. I'll put the 1/4 outside. Then we have e to the u, then du. And then we can solve this like the regular method, since e to the u is the same as e to the x when we're going to integrals and derivatives. You're going to just have e to the u again, so just be 1/4 e to the u. And then this would, if we sub this back in, just x to the fourth, it's be 1/4 x to the x to the fourth. And that'll be your answer. Alright, now that is u substitution. I would suggest just practice these. I don't think I saw how much u substitution when doing some problems in PChem, but uh, I would say just practice just in case. Alright, I think the last part of integrals will be integration by parts, which you're going to be using for something called Hermitian operators. You don't need to learn it currently this week, I believe. Next week, you're going to need to know integration by parts. And they're not, and you don't need to know it. They're going to teach you it in lecture, but it's still a good thing to know. So let's say we have, let's integration. Okay, so integration by parts. I'm just going to go straight to it instead of definition. So let's say we have two functions, f of x. So it's a product of two functions, and we want to solve. We don't have a integral to solve this. So then we do u f of x du f prime of x, and then the opposite will be dv, which will be g of x, and it'll be v, which will be g of x. So f of x will probably be a function like x to the third, x to the fourth, some x to n power, and then as you solve it, it will go straight to 1. When you're doing integration by parts again, again, again. Right here, this would be probably like a function like e to the x, or cosine, or any trig function for that matter. So to do integration by parts, you do this, and f of x times g to the x, and then that would be minus the integral of f of x times, oh wait, sorry, my mistake. It will be g to the x. So it'll be like f prime of x times g to the x. And then we repeat this again. So then we repeat what we did up there. And so this will be like, I just want to show this again. Oh, wait. du is f prime of x. dv would be g of x. And v, which would be, let's just say it's the integral of that uppercase, and you would do all this, and you'll have this term here, and it'll be minus that, yeah, it'll be minus whatever the integration of parts is here. And you do this until the integral is solvable. So you do this until integral is solvable. All right. Let's see what else we got here. All right. So that's all for integration by parts. I will try to do an example of what you're going to need it in another video. So what I'm going to go on to next is imaginary numbers, which is really important to know. So let's just say, so you guys know imaginary numbers, if you take the square root of a negative number, you're going to have I. And so when you multiply I times I, you're going to get a -1, and I to the negative and I to the third, which would be negative 1. Oh, wait, let me just pick I squared. Will be like negative 1 times I, which will be negative I. And it'll be so far when you do it again. And I know I to the fourth is just negative 1 times negative 1 will be 1. All right, so that's what an imaginary number is. It's just the square root of negative 1. And so if we take the complex conjugate, it's the complex conjugate is just basically the opposite of that complex number. Like it has a negative real number instead of a positive real number. So I'll show an example here. So let's just say we have a to the bi, and if we the complex conjugate of that, if we take the complex conjugate of that, would be a plus. This turns I into negative I. So when you take the complex conjugate of that, you will get, and sorry for the background noise, that'll be a minus bi. And the funny thing is, when you multiply by the complex conjugate, so a plus bi times this complex conjugate, you will get, let's see, a squared minus iab plus iab plus b squared. And this will be a squared. So when you multiply it by a complex number's complex conjugate, you always get a real number solution. And this is useful for what we're going to do with wave functions. All right. Let me show another example I didn't put in the notes yet. So let's say we have e to the negative I x, and we want to multiply by its complex conjugate. We take its complex conjugate, so e to the negative I x its conjugate, and this would equal to e I x. Now if we multiply by its complex conjugate, let's see, oh yeah, I x. When you do exponents, it'll be like an exponent. You would be adding these together. These cancel out, so this will just be equal to 1. It is just another example. There's no real parts. I mean, there's no imaginary parts here too. So taking the complex conjugate of a complex number and multiplying it to it will give you a real number solution. All right, guys. Sorry for the long video. I'll be posting some videos also on what YouTubers to watch, like organic chemistry tutor, basically some math review on like stuff to know, and yeah, if you guys want any other examples, just let me know. And thanks for listening.